see the plug there. Better if I do that. Nope. That, I can see the plug. I'm of course going to test it to make sure I've unplugged the right thing. This has been de-energized, that's considered locked out. Our drill press has two-step pulleys and a belt going between the two. So we have 1, 2, 3, 4, 5, 6 steps here, 1, 2, 3, 4, 5, 6 steps here. Each step is a different speed. Okay? So, your best guess, with 6 steps here and 6 steps in the back pulley, how many different speeds can I get?
6, because they have to be on the same level.
Perfect answer. Yes, you can only get 6 steps because the belt has to be on the same step. It cannot be staggered up or down like this. It has to go directly across. Okay? We have a chart way over here showing us the different speeds for different materials and for different size drill bits. If we have a drill bit down at the bottom of 2 inches or 51 millimeters, the maximum speed we can go is 700 RPMs. Okay, so the bigger the bit, the slower you go. And we have another chart in here showing us exactly what speed each of these steps is. So we just have to match that up. So if I want to put in a 3-inch hole saw, there's nothing there that's 300, or sorry, there's nothing there that is 3 inch or 76 millimeters, so we have to go to the slowest speed. Okay, so slowest speed, according to that chart, is 700. According to this chart, we have 460, and then 800, we're at 815, and then 1260. So we can go down to 460 RPM. And that's probably what you want to do with anything that's over 200, just drop it down to the lowest RPM. To do that, you're going to pinch your fingers, and what you need to do is move the belt. So you move the belt down to a smaller pulley. So I'm going to move the belt at the back down to the smaller pulley. That's going to give us a little bit of slack to then move the belt onto the bigger pulley at the front. So I'm just going to push down, and it has moved automatically down to the smallest pulley, right there. And now I'm going to come up to the front, give this pulley a little spin. There. It is down to its slowest speed. Okay? It takes a little bit of practice to not pinch your fingers when you're doing this. So be aware you're probably going to pinch a finger and it'll hurt like hell for a couple minutes, but that's what we got to do. We have a number of features over here. This handle is what lowers the quill, and the quill is what holds the chuck, and the chuck is what holds the bit. So this part is the quill, this part is the chuck, and of course the bits are all these fancy little things we have over here. We have a depth stop here. And the way this works is we have 2 nuts. And if I want to drop it down to a depth of, these are random numbers by the way, that's 100. We have to get 2 nuts up to the same spot and then kind of lock them together. Just kind of twist them together. That way they won't vibrate loose and move up and down the column. Now, I can move it much further. When I said that these numbers are kind of random, it all depends on where the table is. The table can be moved up and down. So to move the table, we have to loosen up this lock here. Everybody see this lock right there?
Yeah.
Okay. And then we can raise and lower the table. And then don't forget to lock it. Now this is not an incredibly precise machine because this now, we have to really cinch up that lock to get it to stop moving horizontally like this. I'm gonna put in this bit. Turn the chuck, it's a 3-jawed chuck. That means that 3 places on the chuck are grabbing onto the key, or sorry, onto the bit. There are some bits that have a 4-sided tang, and the tang is this part that fits in the chuck. Sometimes these are 3-sided, sometimes they're 4-sided, but mostly they're round. If it's a 4-sided tang, it does not fit in an electric machine, not an electric hand drill, not an electric drill press. It fits in one of the old hand crank style drills. Okay, so look for that if you're buying old bits. If it's a 4-sided tang, it does not fit in your drill bits, or in your drills. Okay, so I have a 1-inch bit in here. I'm tightening up the chuck with the key. And now the most dangerous thing you can do in a drill press is just what I've done here. Leave the key in the chuck. Why is that?
Because it's gonna go flying.
Yeah, somebody's gonna come, just turn the power on, and the chuck is gonna start turning at 460 RPM. This key is gonna go flying. That's why it's on a lanyard, so it doesn't go too far. When I was in grade 10 electronics, I was working on a drill press. I left the key in the chuck. I turned it on. It went flying over my shoulder and went through the front door of the electronics shop. Had it hit me, it would have gone through my shoulder. So I was very lucky. So I know firsthand how dangerous this can be. When you are using the key, keep it in your hand and then leave it over there. Okay? All right. I have a 1-inch drill bit, and I am going to drill a hole approximately there. So if you can't see, this is my push stick that I'm going to be carving out on the bandsaw later. But I need to drill a hole, and we will all need to drill a hole right there. No specific locations, just wherever the drill bit's going to fit in here, we need to drill a hole. I'll explain that when we get over to the bandsaw. A 1-inch bit, can somebody tell me what speed I'm allowed to go up to? Take a look at the chart. This is plywood. 700. Okay, so it's at 460 right now, and I can go up to 815. It's probably going to be okay to go up to 815. It's only an extra 100 RPM, so I will move this up. Now I have a little bit of slack in my belt. Put it up to the second pulley up here. Give it a turn.
So it's okay to just, if it's a little higher, just put it to the closest RPM the machine can do?
You can go 1 step up, yeah. There, that's good. This shroud has this little nut and bolt on it. It's only because we lost the knob that's on here. Turning this doesn't do anything. It's just kind of a handle for us. So we just kind of lift it up like that. There is the head of the bolt fits into this little recess. It's not screwed together. Okay? All right, I want to drill that hole. We should always use a fence when we're on the drill press. Very few times you're going to want to do it freehand. So I'm going to move this fence. And these fences are designed so they can kind of fit around the column, kind of. Or we need to drill half a hole in something, we can do that. I'm going to move the fence to, I like that there. I'm gonna have to move a few things. I want my part to be right there. So what I'm gonna do is over here, I'm just gonna lock it. Now I
Push
can-
that up.
Pardon me?
Oh, I see the wheel, I see it, okay.
And you'll find the drill presses all over the shop. They usually have 2 or 3 of these fences somewhere close by. Found these 2 were just back here like this. Okay, I think I'm set to go. So the bit is going to be spinning as I'm looking down at it. It's going to be spinning in a clockwise rotation. So that means that the force of the bit going into the plywood is going to be pulling it against the fence over here and away from the fence over here. So I'm going to want to make sure that I hold it and that this side doesn't come away. With a small little drill bit like this, it's not a big deal. When we start using things like this, there's a lot more force. I have a sacrificial piece of MDF here. That is because this table is getting a little bit worn out. And when I punch through my material, if I have a void or scar like this, it's not going to provide the support on the underside, and it will allow the drill bit to tear out the veneer on the opposite side, or solid wood on the opposite side. That's where I want it. It's not going to drill all the way through, so I can either lower this down or raise the table up. Looks like I'm going to lower the bit down.
You're sure with this, how am I supposed to do it?
Use something to pry it open.
Work smarter, not harder.
Work smarter, not harder. Yep. I really cinched it tight so the table wouldn't do this. That doesn't seem to be an important part right now. I just had my last class tune this thing up.
Well, they didn't do a very good job.
That could be the problem here.